Hey everyone, welcome back to the channel. This is Rahul. Today we are tackling an interesting coding problem from LeetCode, that is partition array according to given pivot. This problem is all about rearranging an array while maintaining relative order, and it's a great test of array manipulation and stability in sorting. Let's break it down step by step. If you are new here, sub my channel for more DSA videos and coding contents. If you like this one, just like it and share your feedback in comments. So this is the question. You are given an integer array nums and a pivot value. Your task is to rearrange the array such that we have some rules here. First of all elements less than pivot come first. Then second, all elements equal to pivot appear in the middle. Third one, all elements greater than pivot appear at the end. And last one, the relative order of element must be maintained within their group. So it means that here, if you see, then here this 9 will keep it first, means the order will not change. 5 will go second since it's less. Then here we have 3, it will go. And whatever elements greater than this will go to right. So it have to be at the middle. So in this way we have to write the code. So I hope you understand what we have to do. So there are some approaches that we can write for this. So first of all we have sorting, but it is not optimal. Means while sorting the array, then pick elements in order. But the problem here is it will take big of n log n time and modifies the original order of elements. Second one is using three list. Here, using three list is for one for the elements less than pivot, second for equal to pivot, and third one that greater than the pivot. Here, we concatenate them to get the result, and it will work at a time complexity of big of n and space complexity also big of n only. The third approach is in place partitioning. It is actually an advanced one. Here we modify the array directly to avoid extra space. It's somewhat tricky to implement while maintaining the order, but actually it's not needed for this problem. As in that case, we will go to the approach 2 because it's simple, efficient, and it maintains order. So the second approach is using three list. So we have our method solution, class solution with method pivot array having two inputs, one array nums and pivot value. So first of all, we need to create three list. This means three arrays which store elements according to that. So I will take the length at first. Nums dot length. Then we have to create the array for less I and another one is result. New done. Then for high. Another one to store the final order elements. have the same size of the input array. Here we are using three arrays because we need to maintain the relative order of the elements. That's the case. Now we need to count and categorize the elements. Means we need to traverse the array nums and divide elements into less array and high array, and we have to go to the count occurrence of pivot. So first of all, we need to initialize some variables for the same. First one is to get the number of pivot occurrence. So we will use count. Another one for index of less array. Next one for high array index. So we have to traverse through the array now. For int I 0, I less than n, I plus plus. Now we have to check if the number less than pivot, we have to add it to add we need to store smaller elements. So if I less than pivot, then plus so if I, we have to go for second condition, where if both are same, both the number and the pivot is same, then we have to increment the count of pivot occurrence. Now third one, where we have to store the larger elements. That's the else condition. High k plus plus nums of I. Okay. Once that's done, we have to construct the output array. So we have to add less values first, then add the pivot count times, then last we have to add the high values. Int index here 0. So we will start from adding smaller elements to the result array. For 0 less than j a plus plus. Here nothing, just keeping the values. Once this done, we have to add the pivot occurrence into the result array. So we're done with plus and same elements. Now we have to go for the higher one. For int 0 a less than key a plus plus result index plus plus notes I of a. So once this done, we have to return the result. Let's run the code. So here we maintain a relative order by storing elements separately, which making this work efficiently, and we preserve stability, which means elements stay in the same relative order. So now discuss about the time and space complexity. Here time complexity is big of n since we iterate through nums once and build result in another pass. Space complexity is also big of n since we use additional arrays, the less, high, and result one. So let's submit this one. So actually this approach is easy to understand and keeps elements in order and runs efficiently. See, it's efficient one, and that's how we efficiently partition an array based on a pivot. If you found this helpful, smash that like button, subscribe for more DSA tutorials, and let me know in comments how you optimize this one. See you in next one. Till that, happy coding.